We are working some calculus problems. We're under continuity and one-sided limits, and this is the section we're in. And don't forget where you're at, or where you should be. We have a piecewise function, and we're wanting to find the limit as x approaches 5 of h of x. Let's bring up the whiteboard. Let's erase what happened in the last problem. And let's write some stuff down. So we had the h of x. Now this is the more traditional way of writing that with a big curly bracket. That's a curly bracket. 7x minus 4, and the domain is x is greater than 5. And then down here we have just the constant 31, and x is less than or equal to 5, and of course 5 is where things get interesting, so that's the reason we're going to look at the limit as x approaches 5 of h of x. Alright, and what I'm going to do over here is draw a graph. Kind of sketch this out. Let's put 5 right here. Okay. Now, let's look at this one up here. What this says is we're going to, because there's not a plus or a minus sign right here, this means that we're going to be coming in from the left and from the right. So let's just do this, since this section is, we'll come in from the left first. And so that means we're going to be using this one here because this says all x values less than 5. So we're coming in from this side here. Alright, including 5. The limit of a constant is just the constant. We can just say that because we're including 5 here. And so let's see, okay, so this is not to scale. I need to say that first off. We're going to include 5, so I put a circle, I filled in dot here, and then of course it's just a horizontal line. Right, horizontal line passes through 31, and so forth. Now this one up here, take the limit as x approaches 5 from the right hand side, so we put a plus sign. This is 7x minus 4, and that is equal to, so if I were just to do direct substitution here, okay, we got 35 minus 4 is 31. Another 31. We have a slope of 7, negative 4, you know, I don't know, it's going to look something like that. You see that? Now, of course, because we're not really allowed to use 5, you know, do the direct substitution, if you had to, we could always choose numbers to the right of 5 that's real close to 5, doing this, you know, in a numerical manner where we're plugging these numbers in and seeing what this number, plugging them in and seeing what the number is actually converging towards. Okay. Now the question is this function h of x, is it continuous on, let's say, the real number line? And this function here is continuous on the real number line. For all x values that's going to be greater than 5, this is continuous, obviously, less than or equal to 5. I should state, though, that remember there was a hole here on the end, okay? But this guy here is what's going to end up filling it in. Things that you have to look for example, we got a test h of 5. Well, h of 5 was 31, and then of course we looked at the limit right here, and the limit actually is 31, okay, because both of these numbers are the same. I should have already stated that. Since that's 31, that's 31, then the limit is 31. Well, this exists and it's 31. This exists and it's 31. They're both the same number. Therefore, it is continuous at this point, and therefore it's continuous on the entire